Hello everyone, let us see now next examples. This is the last lecture of second chapter. Okay, let us see now. We are learning applications of Laplace transform to solve the differential equations. Now earlier point was depend on the solving differential equation, only one differential equation. Now we are going to see the solving of differential equations using Laplace transform where there are two differential equations. Okay, we have already seen one example depend on that. Now let us see the next example. Question is same here. Okay, solve the following differential equation. Okay, dx by dt plus 4 dy by dt minus y is equal to 0. This is the one differential equation in x and y. X and y are the two variables here, and second differential equation is dx by dt plus 2y is equal to e raised to minus t. Okay, x and y are the dependent variable, t is the denominator variable, that is an independent variable. Okay, these are the initial conditions given, that is x of 0 is equal to y of 0, both values are 0. We are going to use in the formulas. Okay, now let us see the solution of this differential equation. First we have to convert these differential equations into dash forms. Okay, where dx by dt means x dash, dash is derivative of x with respect to obviously everywhere t. X dash plus 4 y dash minus y is equal to 0. Second one is x dash plus 2y is equal to e raised to minus t. These are our original two differential equations. Call them as 1. Okay, taking Laplace, obviously next step will be taking Laplace on both sides of both the equation. What will be the next step? L of x dash plus 4 constant. Ultimately you have to take out all the constants from Laplace, out of the Laplace. Here 4 is a constant, take it outside. L of y dash minus L of y is equal to 0. RHS side is 0 here. Now here also L of x dash plus 2 L of y is equal to RHS side L of e raised to minus t means Laplace transform of e raised to minus t is 1 upon s plus this 1. Okay, this is the formula for Laplace. In this application of Laplace, you have to think of all the formulas of Laplace and inverse Laplace transform also. Okay, now using formula of L of x dash and L of y dash, here in these three places we have to put the formula. What is the formula for L of x dash? Minus x of 0 plus s of L of x. Okay, plus 4 as it is. L of y dash formula is minus, just replace x by y here, minus y of 0 plus s into L of y. This minus L of y is equal to is as it is equal to 0. Okay, now second equation is as it is minus this same formula plus 2L of y is equal to 1 upon x, yes, plus 1. Okay, now we are already given the initial conditions here, x of 0 and y of 0 is 0. Put these values in these equations, we get this equation becomes yes L of x plus 4 yes L of y minus L of y is equal to 0, and this is s into L of x plus 2 L of y is equal to 1 upon s plus 1. Okay, now these two are same, that's why we are going to eliminate L of x here by subtracting this equation from this equation. Okay, now subtracting, we get this, all signs gets reversed, here minus minus and here also minus, this two gets cancelled. That's why L of y here in these three terms L of y is common, take it outside. What is the remaining term? 4s minus 1 minus 2. Okay, is equal to, this is minus term, 1 minus 1 upon s plus 1. Again minus 2 minus 1 becomes minus 3 here. Rest of the terms as it is, minus 1 upon s plus 1. Okay, therefore here L of y is equal to, now take that term on this side, we get 1 minus 1 upon s plus 1 as it is, and that term will come to denominator on RHS side, that is 4s minus 3. Okay, now that's why what is our motto? We have to just solve the differential equation, means finding out value of x and y. We are going to have two answers, one is x, value of x, and value of y in terms of t. Okay, That's why here at this particular step we are now finding y. Okay, and once we find y, ultimately we can easily find out other variable by putting this answer in the any one of the equation, earlier equation. Now here take y as it is, take L on that side, we get L inverse of this term. Okay, now in this equation we have to find out inverse of this term. Okay, and now this denominator contains two factors. Okay, we are obviously going to use partial fraction method. One factor is linear, other factor is also linear, because yes, power of yes is 1, here also power of yes is 1, that's why it is called a linear factor. Type 1 for partial fraction we are going to use here. For that also, here coefficient of yes in any inverse Laplace transform should be 1. Coefficient of yes, coefficient of yes square in every formula there is 1. That's why in this step also you can skip this step also and do it afterward, but before that if you take outside this 4 it becomes very easy to find out the inverse. Okay, that's why we are going to use this step here only. Just take this 4 here, yes coefficient is 1 in this factor, that is okay, but here yes coefficient is 4. Ultimately we have to take this 4 common afterwards also if you are not going to use this step here. That's why here only we have to get this 4 outside of the denominator. This is a multiplication, that's why we can take 4 outside of this bracket and also take minus also. Okay, we get minus 1 by 4 outside of the inverse, we get L inverse as it is, this factor as it is, and here by taking 4 outside it becomes yes, and here becomes 3 by 4. Don't worry about this fraction because it is just a number. Okay, now we have to find out this inverse by using obviously partial fraction. Now consider this fraction, that is 1 upon s plus 1 and s minus 3 by 4. Obviously these two are linear factors. Okay, that's why we are going to apply type 1 for the type 1 method for the partial fraction, that is a upon first factor plus b upon this is second factor. Now again I am going to solve this equation because fraction is there, that's why obviously or otherwise you can solve it by your own easily. Okay, now cross multiply, next step will be taking LCM on the denominator and cross multiply, we get this number. Now both the side numerator we are going to compare. Okay, therefore it is comparing the numerator, we get 1 is equal to numerator of this term, this is equal to a into this plus b into this numerator whole. Okay, now what is the next step? We are going to find out the values of a and b by substituting proper values of yes, so that other variable becomes 0 and we can get one variable value. For that first put yes is equal to get a, b should be 0, or but to get b, a should be 0. That's why put s is equal to here 3 by 4, opposite of this, so that this term becomes 0, we get b value. Okay, now put s is equal to 3 by 4 on both sides, we get 1 is equal to this b into 3 by 4 plus 1, that is 7 b by 4 is equal to 1, that's why b is equal to 4 by 7. Okay, now we get one constant, that is b. Now to find out a, b should be 0, that's why put s is equal to minus 1 here, both the side we get 1 is equal to a into minus 1 minus 3 by 4, that is minus 7 by 4, that's why a is equal to this term gets on that side minus 4 by 7. Okay, this is a regular procedure for partial fraction method. Okay, we have already done this. Now what is the next step then? Putting this value in this above equation, what we get, y is equal to 1 by 4. Already we are what we do generally, we put this value in this equation. Okay, and then we put this value in this equation. Now we can skip this step and directly we can put this value in this equation and write down these two equation as it is. That is 2 implies y is equal to, this is y is equal to minus 1 by 4 as it is, L inverse as it is, and this term is this term, that is this term. Putting this value in this a and b, we get minus 4 by 7 upon s plus 1 plus 4 by 7 s minus 3 by 4. Okay, directly we are going to put this value in this equation. Therefore this is take again this minus outside of the term minus 4 by 7 is a common from the numerator. We get outside, we get minus gets cancelled, 1 by 4, this is 4 by 7 outside, this term becomes plus and this term becomes minus. Okay, now 4 gets cancelled, 1 by 7 as it is. And what is inverse of these two? These are the linear factors, linear this thing. This is e raised to minus t inverse and this is e raised to plus 3 by 4 t. Okay, this is minus as it is. This is the one solution we are getting, that is the y value. Now what is our next motto? We have to find x value also. That's why by earlier basic examples, here in this example there are two basic equations given in the example itself. That's why we can put this value of y in any one of the equation to get x. Okay, whatever the simplest equation is, we can put in that equation. By observing these two, what is the minimum terms here on LHS side is this term. Okay, these are the simplest this thing. That's why we can put here value of y, we can get easily value of x. That's why consider this equation, that is x dash is equal to, now what is our motto? We have to find out x. That's why put keep this x on LHS side and take this 2y on LHS side. We get x dash is equal to e raised to minus t as it is. Okay, and this term becomes minus 2y. Okay, now put this y value here. We get x dash is equal to e raised to minus t and this becomes minus 2 by 7 here. 2 get multiply those each term and take 1 by 7 inside the bracket. We get 2 by 7 e raised to minus t, minus plus here, this minus plus 2 by 7 e raised to minus plus 3 by 4 t. Okay, this is the value for x dash. What do we want? X. What is the dash meaning? Derivative of x with respect to obviously t. Okay, in the example itself, derivative is with respect to t. That's why to eliminate, to find out x from x dash, you have to remove x dash, means we have to apply the opposite process of derivative on both sides. What is the opposite process of derivative? That is the integration. Okay, now taking integration on both the side, what we get? Derivative integration gets cancelled. Answer becomes on LHS side x, which is our answer, which is equal to taking integration on both the side. What is integration of e raised to minus t? Obviously with respect to t, e raised to minus t upon minus 1, minus 2 by 7 as it is, e raised to minus t, again e raised to minus t upon minus 1, plus you can add these two later on or here also, plus 2 by 7 e raised to plus 3 by 4 t upon 3 by 4, and it is a indefinite integral. Okay, because limits are not there, that's why we have to take c additional here. It is an integration constant, we already know this. Okay, that's why this is a c plus that is an integration constant. Now simplify this, take e raised to minus t common from this t, two terms, we get minus 1 here and minus plus 2 by 7 here, plus this is 2 by 7 as it is, this comes to numerator 4 by 3 e raised to plus 3 by 4 t plus c. Therefore x is equal to this addition, minus 1 plus 2 by 7 becomes minus 5 by 7 e raised to minus t, plus this is 8 upon 21 e raised to 3 by 4 t plus c. Okay, now this we have to find out. Integration constant we can find out depend on the initial conditions. Already initial conditions are given in the example. Okay, this is a x value, this is the answer for x, and we have to find out c. That's why we have to search where is the initial condition for x in the example. What is the initial condition for x? This one, x of 0 is the initial condition, it gives 0, it is equal to 0, this we are going to use. Okay, where c is the integration constant, can be calculated by using initial condition on x or of x, that is x of 0 is equal to 0. What is the meaning of this? That is, put x is equal to 0 and t is equal to this bracket value is value of independent variable, that is t. That's why at t is equal to 0, x be equal to 0. This is the meaning of this x of 0 is equal to 0. In above equation, put this value, we get x is equal to 0 is equal to, everywhere t becomes 0, we get 5 minus 5 by 7 plus 8 upon 21 plus c. Okay, that's why simplify this on RHS side, we get c is equal to 1 by 3. Okay, that's why putting this value again in the answer, we get x is equal to this as it is, both the term, and plus 1 by 3 is the c value. Okay, this is the one solution and this is the other solution. Value of x and y is this solution of this two differential equation using what we are using, only Laplace transform. This is the application of Laplace transform. Okay, now here this is some homeworks for you. 84 example is there. D square minus 3 into x minus 4y is equal to 0 and x, so the question is same. Okay, solve. X plus d square plus 1 into y is equal to 0. What do you mean by d square? Double derivative only. Okay, d means derivative, d square means double derivative. That's why we have to find just first given these are independent condition, x is equal to y is equal to dy by dt is equal to 0 and dx by dt is equal to 2 at x is equal to, at t is equal to, it must be t. Okay, at t is equal to 0. Okay, now let us rewrite this question in our usual notation. D square of x means double derivative of x, x double dash, take this x inside, we get d square of x is x double dash minus 3x minus 4y is equal to 0 and x plus this is d square y means take y inside, do a double derivative of y, that is y double dash plus y is equal to 0. This is our usual notation. Okay, now we have to these are the initial conditions, we have to write in the bracket form. X is equal to y is equal to dy by dt is equal to 0. These are 3 conditions and here one more condition. There are total 4 conditions. At t is equal to 0 means x of 0 is equal to 0, y of 0 is equal to 0, dy by dt means y dash of 0 is equal to 0 and dx by dt means x dash, okay, is equal to x dash 0 means t value is equal to 0 is equal to 2. These are the initial conditions. Okay, now solve by using earlier method as usual. Answer should be this. Okay, this is the homework for you. Now next, this is also one homework for you. Dx by dt minus 2x plus 3y is equal to 0 and dy by dt plus 2x minus y is equal to 0. These are the initial conditions. Answer is this. Okay, now this is the end of the chapter. Now let us see some special examples, some different kind of examples in the in this total 2 chapters. Okay, 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 let us see some special kind of examples which are different from earlier any kind of examples. Okay, first, L inverse of, where to find out, what is the question, where to find out inverse Laplace transform of this term. Okay, now here 1 upon s minus 1 and root o s, we cannot use here partial fraction because root s is there. Okay, and no any other method except convolution theorem can be used here. Okay, therefore let us use here convolution theorem. First, what do you mean by convolution theorem? What is the method for convolution theorem? We have to split this function into two partials, where we can easily calculate their inverse Laplace transform. Okay, that's why first take it, what is the simple term here? S minus 1 is the simple term. That means its inverse is very simple as compared to root s. That's why we call it as second function, that is phi 2. We already know this, all these things, where in convolution theorem two functions we have to split, phi 1 and phi 2, where phi 2 function should be easier. That's why this one is easier, that's why we call it as phi 2s. Let phi 2 of s is equal to 1 upon s minus 1 and phi 1 is equal to 1 upon root s. We in the initial step only you have to judge the which term is simple and which term is complicated. Okay, 1 upon root s. What is the root s means? S raised to half. Okay, that's why now next step will be inverse, finding out the inverse of these two. That's why L inverse of phi 1, first one take phi 1 is equal to L inverse of 1 upon s raised to half. S raised to half is 1 upon s raised to n formula here. What is the formula for inverse? That we have to use there are two formula for 1 upon s raised to n inverse. One is in terms of fraction, factorial, and in terms of second one is in terms of gamma function, where if n is a fraction we can use gamma function formula, and where if n is a whole number we can use factorial function formula. Here s raised to half is there, that is a fraction is there, that's why we are going to use gamma formula here. That's why n inverse of this means t raised to n minus 1, that is half minus 1 upon gamma n, that is gamma half. What is gamma half? It is a root pi. It is a well-known constant. T raised to half minus 1 is minus half. Therefore, L inverse of phi 1, yes, we get 1 upon root pi t raised to minus half. Call it as f1t. Phi 1 inverse is f1. Okay, this is a regular notation. Now take L inverse of phi 2, that is L inverse of e raised to this is 1 upon s minus 1 is e raised to t. Okay, L inverse of phi 2. Phi 2 is 1 upon s minus 1 function. That's why L inverse of 1 upon s minus 1 is e raised to plus 1 t. Call it as f2, and phi 2 inverse is f2. Okay, now once we calculate both the inverse, now we have to use convolution theorem. First write down the let us write the convolution theorem statement. What is the statement of convolution theorem? L inverse of phi 1 into phi 2 is equal to integration 0 to t f1 u into f2 t minus u du. Okay, that's why integration 0 to t, put this value of 1 of u. What is f1 of u? Just replace t by u here in this in the term. That is 1 upon root pi is a constant as it is. T replaced by u raised to minus half into f2 t minus u. What is f2 t minus u? Just replace t by u, t minus u here in this function, that is e raised to t minus u du as it is. Now I have to split this, take 1 by root pi as it outside of the integration because it is a constant. U raised to as it is, e raised to t into e raised to minus u. Split this two, okay, into du. Now here integration is with respect to u here, and these three out of these three terms, these two terms contains only u. That's why this is a constant term regarding this integration. That's why I take it outside. We get e raised to t upon root pi as it is 0 to t u raised to minus half e raised to minus u du. Okay, now we have to use here error function of root t method. We have already see this such type of example earlier, one example only, because this example cannot be solved by part rule, because exponential is okay, that is okay, e raised to minus u is there, but u raised to, that is an arithmetic term. Liet in Liet rule, a is the arithmetic term, where arithmetics in rise should be positive one. If it is negative, that term's integer derivative will not be zero anywhere. That's why u by parts rule will not be end somewhere. That is the only reason we cannot use by part rule here. That's why we have to go through the known integration, that is error function of root t. We know this definition, that is 2 upon root pi integration 0 to root t e raised to minus x square bx. This is a standard definition of error function of root t. We have to convert this integration into error function of root t. For that, obviously here e raised to minus x square we want, and here e raised to minus u is only there. That's why the ultimate or logical substitution will be put u is equal to x square. Okay, that's why put u is equal to x square substitution. In this example we get derivative on both sides, u is equal to 2x dx as usual. Now we have to take we have to check out the limits of u. Earlier variable is u and new variable is x. Earlier variables limits are 0 and t. Okay, now we have to find out new limits of x. Put u is equal to 0 here, we get x is equal to 0. Put u is equal to t here, take square root on both side, we get x is equal to root t. Okay, these are the new roots. Now put all this substitution here in this example, we get L inverse LHS side as it is. 5 and 5 2 is equal to e raised to t upon this root pi as it is. Integration becomes 0 to root 2 limits. And here u, what is u? X square raised to minus half. And e raised to minus u means e raised to minus u is x square. Okay, du is 2x dx. Okay, now x raised to 2 gets cancelled, x raised to minus 1, this 2 gets outside as it is, e raised to minus x square and this x. Now again x raised to minus 1 means 1 upon x, this x gets will be cancelled on next step. That's why it becomes e raised to t 2 as it is upon root pi as it is, integration 0 to root t as it is, e raised to minus x square dx. Now this is the standard definition of error function of root t. Okay, this is the answer for our question. Now let's see next special example. Let us see the next example, that is 91 example. 91 it is here. 97th example. This is 86.1. L inverse of s upon, we have to find out inverse Laplace transform of this function. It is numerator is s, denominator is s raised to 4 plus 4 a raised to 4. Using partial fraction, this is given, we have to use partial fraction. For partial fraction, we need denominator, in the denominator more than one factor. Okay, but it is only one factorial. That's the that's why we have to logically we have to convert this one factor into product of two or more factors for using partial fraction. That's why we have to factorize this term. But in this denominator, middle sign is plus. If it is minus, it is very easy to factorize this term using a square minus b square formula. But that is a plus sign here, that's why we have to, but we don't have a square plus b square formula in the mathematics. That's why we have to convert this fraction by using some adjustment into that formula where we can use a square minus b square. Okay, now consider this factor s raised to 4 plus 4 a raised to 4. Okay, what is the we have to adjust square here. By observing this two terms, which square we can adjust here. Here s raised to 4, that's why first term we can write s square. Okay, now this is obviously the last term, second term, because this is not the middle term, because s raised to 4 is not here or s square is not here. That's why this is obviously the second term. What is the second term? 2a square here. That's why the second term will be 2a square. Okay, this is the, we already seen so many times how to adjust square here. Now if you want to adjust this square here, we have to just equalize this term by subtracting or adding the extra term we are getting. Okay, we are taking. Now expand this. For finding out that extra term, we have to go the reverse way. We have to expand this term. What is the expansion of a plus b bracket square? A square, that is s raised to 4, plus b square, that is 4a raised to 4. And the middle term we are getting extra here. Okay, that is, what is the middle term? 2ab, that is 2 here, that is 2 times s a into b. Okay, this is the extra term. What is the extra term? 4 a square, s square is the extra term here. We have to plus extra term we are taking extra, that's why we have to subtract this, and ultimately you can do that. What is the square here? This is 2as square. This term we are taking extra, that's why we have to subtract from this term. Understand this adjustment? Okay, now this 2 becomes equal. Now we can get a square minus b square formula here. This is a term, this is b term. That's why a square minus b square formula is a plus b into a minus b. What is a? This is a square plus 2a square. What is b? 2as. A plus b into a minus b. That is 2as. Okay. In this way, this s raised to 4 indiced expression or denominator function, denominator term we split into two factors where two factors are quadratic factors. And we can, in this case, we can use partial fraction by using type 3 method for partial fraction. How it can be, right? S upon s raised to 4 plus 4 raised to 4 becomes s upon these two factors here. Okay. Now use partial fraction here. How to use? For first partial fraction, as plus b upon first factor plus bs upon cs plus d upon second factor. Take this term into middle, and this is a constant at the end. Okay, now you can solve this by your own by cross multiplying and comparing the coefficients, comparing the numerator, finding out values of a, b and c and d, and you can write this in terms of partial fraction and solve this using partial fraction method, and your final answer should be this. Okay, after finding out ABCD values, you have to split this denominator into you have to adjust this denominator into a square plus a plus b bracket square, that is s plus a bracket square, this term after finding out ABCD values. What is this quadratic adjusted here? Bracket square, complete bracket square, a square plus 2ab plus b square, that is a square we are taking extra, or a square adjust with this a square. Okay, and after that, and what is the adjustment for here? Just take minus. Okay, and after that you can use the exponential second shifting property for this, and after that you will get this answer. Okay, now next will be example is L inverse of s cube upon s raised to 4 minus a raised to 4. Here is minus sign is there, that's why we can easily split this a square. See here no adjective is given, just way to find out inverse Laplace transform using any method, but this example can be solved by using partial fraction method only. Okay, because see, in the denominator contains a square, s raised to 4 minus a raised to 4, use here a square minus b square formula, we get a plus b into a minus b. Okay, why? Because it is like this, a square minus b square. Okay, that's why it is a plus b into a minus b. And once we get quadratic factor, if it is s square, you can use convolution theorem also. Here s cube is there, that's why you cannot split into two easiest functions, so that we can use the convolution theorem. That's why strictly use here partial fraction method. Your answer is this. Okay, now let us see next example. L inverse of s upon s raised to 4 plus s square plus 1. Okay, now we have to again do here adjustment for, or we have to adjust square here, perfect square, that is s raised to 4 plus s square plus 1. What is the first term? S square will be a first term. Okay, and this is obviously middle term, and last term, see here plus 1 is there. Okay, that's why we are going to adjust this term as a plus b bracket square, where here adjusted s square plus 1 bracket square. Okay, expand this term, what we get? S square is s a square plus 2ab, that is 2a square plus b square is there. Okay, now what is our original denominator? S raised to 4 is there, 1 is there, and 1 s square is there. What we are taking? 2s square extra, that's why we have to subtract minus s square here. This will get s square. Okay, this is the adjustment for this example. Now again a square plus b square formula you can use here, a plus b into a minus b. Again use partial fraction here and solve this example. This is a homework for you. Already we have I think we have already solved this example in partial fraction method. Okay, now next example is L inverse of 1 upon s square plus 2s plus 5 its bracket square. Using we have to find out inverse using convolution method or convolution theorem. For convolution theorem we have to split this example into two. Okay, obviously we can split into two as 1 upon 1 bracket, and that is a square plus 2s plus 5. Okay, now to find out inverse of this two, what is the inverse? How to find out? Just expanding the square or adjusting the square. That is s plus 2 by 2, that is 1 bracket square can be adjusted here. We have already seen such type of examples. That is a square plus 2s plus b square, that is plus 1, and plus 4 becomes plus 5. Okay, they call it as phi 1 of s obviously. Now we have to find out inverse of this phi 1, which is equal to inverse of this term. We have to, you're going to use first shifting property, that is e raised to minus 1t, take outside, L inverse of 1 upon s square plus, just plus 1 delete from there, that is a square plus 4. What is the inverse of this? That is sine 1 by 2 outside and sine 2t. Call it as f1t. Okay, now what is phi 2? Phi 2 is the same term because square is there, that's why the second factor will be the same factor. That's why phi 2 is equal to this, and elements of phi 2, just repeat these things, just write down as it is the answer. E raised to minus t upon 2 is equal into sine 2t. Phi 2, that is phi 2 inverse is f2. Okay, now once we calculate inverse of both the function, now use the convolution theorem, that is by convolution theorem. L inverse of phi 1 into phi 2 is equal to integration 0 to t f1u into f2t minus u du. Okay, now put the values. L inverse of phi 1 into phi 2 means multiplication of these two, that is original example, that is 1 upon this bracket square. Okay, integration 0 to t f1u into f2t minus u du. Put the value. What is it mean by f1u? Both the functions are same. Here f1u means just replace t by u here. We get e raised to minus u upon 2 sine 2u. And into f2t minus u means just replace here t by t minus u everywhere. We get e raised to minus t minus u upon 2 into sine 2 as it is, and t minus u du. Okay, this is the substitution of functions here. Now once we substitute all these values here, we are going to split this, or we are going to solve this integration. Okay, here 1 by 2 into 1 by 2 1 by 4 take outside, e raised to minus u sine 2u as it is. Now split this, e raised to minus t into minus minus plus e raised to minus plus u. Sine take 2 inside the bracket, 2t minus 2u du. Now in this term, e raised to minus t is a constant because integration is with respect to u. Take outside, e raised to minus t upon 4 is as it is, 0 to 2 as it is. Sine 2u into this e raised to minus u into e raised to plus u becomes 0. In that 0, e raised to 0 becomes 1. Sine 2u as it is, sine 2t minus 2u as it is. Okay, and this integration you can solve by using formula sine a sine b. Okay, use the formula here and solve the integration. Answer will be this. This is a homework for you. Okay.